Hello friends, I welcome you to my YouTube channel MacPM. In today's video, we will try to find out the force exerted by this water jet or fluid jet, which is moving with a velocity v on a curved symmetrical moving plate, which is moving with a velocity u. So let's try to find out. First of all, we know that force F is rate of change of momentum. So rate of change of momentum will be m1 initial momentum minus final momentum divided by time, which is equal to mass into velocity. Momentum is mass into velocity. So m1 v1 minus m2 v2 divided by t. Which, here m1 and m2 are equal because mass flow rate from this jet is equal. So m by t v1 minus v2. This is the force. Here m by t is mass flow rate. We can write it like m dot v1 minus v2. Now, as we know that this jet is moving with a velocity v and this plate is moving with a velocity u, so relative velocity will be v minus u. So this will be the relative velocity with which this jet is striking this plate. So you can see from here it is striking with a velocity v minus u. So and after this striking this plate, the fluid will be dispersed and it will flow along the surface of this curved plate and exit here at angle theta with relative velocity v minus u. So components of this velocity will be v minus u cos theta and v minus u sin theta. So what will be the mass flow rate m dot? So m dot is density into volume per unit time. So density is rho into volume per unit time is area into velocity. But here velocity is v minus u, relative velocity. So it will be equal to rho a v minus u. This will be mass flow rate. So we can see that F is rho a v minus u into v1 minus v2. v1 is velocity at inlet, v2 is velocity at outlet. So if we have to find the force in x direction or horizontal direction, then it will be rho a v minus u, and v1 is v1x minus v2x, which will be equal to rho a v minus u. What is v1x? v1x is velocity at inlet in x direction, which will be equal to v minus u, because velocity at inlet is v and this plate is moving with u. So relative velocity at inlet is here is v minus u minus v2x. v2 is x is, we have already seen that, v minus u cos theta, but this is in opposite direction to the initial velocity, so we have to write it as minus v minus u cos theta. So it will be equal to rho a v minus u. This is v minus u. We can take it common in bracket 1. This minus will become plus cos theta. So it will become fx is rho a. We can take v minus u out of the bracket. v minus u all to the square into 1 plus cos theta. So this is force exerted in x direction. Similarly, if we have to find out the force exerted in y direction, then we can find out in similar fashion. So Fy will become rho a v minus u in bracket v1y minus v2y equal to rho a v minus u. What is v1y? The relative velocity in y direction at inlet, which is 0 because this is horizontal movement, and v2y is v minus u sin theta. v minus u sine theta. So it will be equal to minus rho a v minus u whole to the square into sine theta. So this is force in vertical direction. Okay. Now we have to find the work done. So work done per unit time W2 is force. Work done is force into displacement. So work done per unit time is force into displacement by time, which is equal to force into velocity in direction of force. This displacement is in direction of force, so this velocity is also in direction of force. So we will find Wx in x direction. Work done per unit time is force in x direction, which is rho a v minus u to the whole square into 1 plus cos theta into what is velocity with which plate is being displaced in x direction is u. So it will be rho a v minus u to whole to the square into u into 1 plus cos theta. This is the work done in horizontal direction by this jet on this plate. Work done in vertical direction will be 0 because there is no displacement or no velocity in vertical direction. So I hope you understand this problem. If you have any problem, then please ask in comment section, and thanks for watching my video.